We are about to discuss the chapter 21 of this book by Luis Frenzel Jr. And the chapter 21 is all about wireless technologies. I'm Carol Ana Ala and I will discuss the half of this chapter. Wireless technologies. This chapter describes the more widely used of these popular systems. These are primarily short-range systems that have a range of a few inches up to several miles depending upon the application. And these are the topics covered in chapter 21. First is the wireless LAN. In this figure, you can see the types of wireless LANs. In letter A, the first type is the access point extension to a wired LAN. In the letter B is the public access point via an internet service provider. In figure A, here, a wireless access point or AP is connected to an existing wired LAN, usually through an Ethernet switch. This AP contains a transceiver that can cover a specific geographic area, usually inside the building. This area usually extends out to no more than about 100 meters, but generally, the range is less due to the great signal attenuation of the walls, ceilings, floors, and other obstructions. PCs or laptops within that range and containing a radio modem can link up with the AP, which in turn connects the PC or laptop to the main LAN and any services generally available via that LAN, such as email and internet access. In letter B, here the AP is connected to the main LAN, or more commonly to an internet service provider or ISP, by way of a long-range interconnection such as a hardwired T1 or T3 line or a microwave relay link such as WireMax. Wireless LAN or wireless local area networks. Within a company, government agency, hospital, or other organization typically use C85 or C86 and shielded twisted pair as the transport medium. However, more and more wireless extensions and even complete wireless LANs have become more common now that reliable, low-cost wireless modems are available. What makes the wireless LAN so appealing is that it offers flexibility, convenience, and lower costs. Wireless access points or AP. Access points are more commonly known as hotspots. Some cities are installing municipal hotspots. Anyone with a laptop equipped with a LAN modem interface can link up to the AP and access his or her email or the internet. There are hundreds of thousands of hotspots around the world. As long as the computer is within the range of the AP, the connection is automatic. Another growing use of wireless LANs is in the implementation of home networks. As more and more families become multi-PC users, there is a need to interconnect each PC to a broadband internet connection such as a DSL or cable TV line. It allows each user to access email or the internet or to share a common peripheral such as a printer. Most homeowners do not want to wire their homes with C85 or 6 cable at great expense. Hardware of wireless LANs. The hardware devices in a wireless LAN are the access point or the gateway or router and the radio modems in the PCs. The access point is a box containing a transceiver that interfaces to an existing LAN by way of C85 or C86, wiring. It gets its DC operating power via the twisted pair cabling. The IEEE 802.3 AF standard related to furnishing DC power over the network cable is referred to as Power over Ethernet. In a home network, the gateway or router is designed to attach to the DSL or cable TV modem with C85 or C86 cable. It often attaches to one of the PCs in the home network cable. Zigbee and Mesh Wireless Networks. Zigbee is the commercial name for another PAN network technology based on the IEEE 802.15.4 wireless standard. Like Bluetooth, it is a short-range technology with networking capability. It was designed primarily for commercial, industrial, and home monitoring and control application. Zigbee is designed to operate in the license-free spectrum. There are 3 basic band versions. The data rates are low, but most applications are simply transmitting sensor data or making simple on or off operations. The standard supports 3 topologies: star, mesh, and cluster tree. The most commonly used are the star and mesh. These network topologies are made up of 3 types of Zigbee nodes. First is the Zigbee Coordinator or ZZ. The ZZ initiates a network formation. There is only one ZZ per network. Second is the Zigbee Router or ZR. The ZR serves as monitor or control device that observes a sensor or initiates off or on operations on some end device. And last is the Zigbee End Device or ZED. The ZED is simply an end monitor or control device that only receives data or transmits it. In mesh topology can greatly extend the range of the network and enhance its network reliability or robustness. As for applications, Zigbee can address a wide range of wireless needs. It was designed primarily for monitoring and control. And these are some popular applications of Zigbee. WiMAX and Metropolitan Area Networks. Metropolitan Area Networks are primarily fiber optic networks, most often SONET rings, that connect enterprise LANs to WANs or the Internet backbone. Another typical metropolitan area network is a local cable TV network. A new wireless contender for metropolitan area networks is known as WiMAX. It's definitely by IEEE 802.16 standard. It was developed to provide a wireless alternative to consumers for broadband internet connections. And these connections are now dominated by cable TV and DSL, but with the new WiMAX standard, Wireless Internet Service Provider, may soon be offering wireless broadband connections. The primary applications will fit into 2 basic categories: point-to-point or P2P or point-to-multipoint or PMP. The point-to-point mode is for applications requiring the transfer of data between 2 points, while the PMP or point-to-multipoint mode is a broadcast mode from a central base station to multiple surrounding nodes. In this mode, WiMAX serves as a WISP for homes or business, WiMAX uses a 256 carrier OFDM system with adaptive modulation. The next topic will be discussed by Leah and Torres. PANs and Bluetooth. A personal area networks or PAN is a very small network that is created informally or on an ad hoc basis. A PAN typically involves 2 or 3 nodes, but some systems permit many nodes to be connected in a small area. PAN can be wired, but today all are wireless. The most popular wireless PAN system is Bluetooth, a standard developed by the cell phone company Ericsson for use of cable replacement. Bluetooth is a digital radio standard that uses frequency hopping spread spectrum in the unlicensed 2.4 GHz ISM band. If another Bluetooth device comes into range, the Bluetooth devices automatically interconnect and exchange data, and these devices form is called a piconet. A piconet is the linking of one Bluetooth device that serves as a master controller to up to 7 other Bluetooth slave devices. Bluetooth devices can also link to other piconets to establish larger scatter nets. Wireless LAN standards. One standard for wireless LANs has emerged as the most flexible, affordable, and reliable. It is known as the IEEE 802.11 standard. It is available in multiple forms of different needs. The 802.11b standard specifies a maximum data rate to 11 Mbps. This rate is achieved only under the most favorable path conditions. Increasing range or noise causes the rate to automatically drop off to 5.5, 2, or 1 Mbps, which helps ensure a reliable connection despite the lower speed. The newest standard is the 802.11n version. It uses the 2.4 GHz band and OFDM. A primary feature of this standard is the use of multiple input, multiple output antenna systems to improve reliability of the link. The basic security protocol is called Wired Equivalent Privacy or WEP and uses the RC for encryption, standard, and authentication. WEP may be turned off or on by the user. It does provide a basic level of security. However, wired equivalent privacy has been cracked by hackers and is not totally secure from the most high-tech data thieves. Two stronger encryption standards called Wi-Fi Protected Access or WPA and WPA2 are also available in several forms to further boost the encryption process. The IEEE also has a security standard called 802.11i that provides the ultimate protection.
I will be discussing the infrared wireless. The most widespread wireless system was infrared light for short-distance data communication. The most widely used is the wireless remote control on TV sets, VCRs, and on most audio CD stereo systems. Infrared has also been used for wireless fans and LANs because light travels in straight lines. There must be a clear path from transmitter to receiver for the system to work. Let's proceed to the discussion of remote control. Almost every TV set sold this day has a wireless remote control. Products that also have remote controls including VCRs, cable, TV converters, DVD players, and some ordinary radios. All these devices work on the same basic principle. A small handheld battery-powered unit transmits a serial digital code via an IR beam to a receiver that decodes it and carries out the specific action defined by the code. A TV remote control is one of the more sophisticated of these controls, for it requires many codes to perform volume control, channel selection, and other functions. The IR source is usually one or more IR LEDs. Two or more LEDs are used to ensure a sufficient level of IR radiation to a receiver in the TV set. An IR receiver is shown. The pin IR photodiode is mounted on the front of the TV set where it picks up the IR signal from the transmitter. The received signal is very small despite the fact that the distance between the transmitter and the receiver is only 6 to 15 feet on average. Besides remote control, the primary application for IR data communication is in short distance links between computers and printers. For IR, short distance typically means up to 1 meter. Under some conditions, the distance can be extended up to 9 meter maximum, and there must be a clear line of sight between transmitter and receiver. Figure 29 shows a block diagram of an IR receiver. It connects to interface circuitry in the PC or PDA. The interface is typically a small embedded controller inside the computer or PDA. It can also be a part of the PDA controller. The encoder puts the serial digital signal from the PC or PDA into the proper format for transmission. A high current bipolar transistor or MOSFET drives one or more IR LEDs. The receiver consists of the pin diode that picks up the IR light from a nearby transmitter. This signal is amplified and shaped and then sent to the decoder, which recovers the original data. The most widely used IR data communication system was developed by Hewlett-Packard in the early 1990s. It has since become an international standard that is maintained by the Infrared Data Association or the IRDA. The complete interface and system are referred to as IRDA. The systems are designed for short range. The low power version has a range of 20 to 30 cm. The maximum usable range is 8.9 meters. Most IR LEDs operate in the 850 to 900 nanometer range. Although TV remote controls are use a modulated IR beam, IRDA does not. It uses baseband transmission that require encoding and decoding. Another growing wireless technique is radio frequency identification or the RFID. You can think of it as the wireless version of the barcodes. This technology uses thin, inexpensive tags or labels containing passive radio circuits that can be asked by a remote control wireless interrogation unit. The tags are attached to any item that is to be monitored, tracked, accessed, located, or otherwise identified. The basic concept of RFID is illustrated. The tag is a very thin label-like device into which is embedded a simple passive single-chip radio transceiver and antenna. This chip also contains a memory that stores a digital ID code unique to the tag item. For that item to be identified, it must pass by the interrogation or reader unit, or the reader unit must physically go to a location near the item. Longer range systems cover a complete building or area. The reader unit sends out a radio signal that may travel from a few inches up to no more than 100 feet or so. The radio signal is strong enough to activate the tag. The tag rectifies and filters the RF signal into direct current that operates the transceiver. This activates a low-power transmitter that sends a signal back to the interrogator unit along with its embedded ID code. The reader then checks its attached computer whether it notes the presence of the items and may perform other processing tasks associated with the application. Some RFID tag configurations are shown in Figure 2115. They consist of a flat spiral inductor and capacitor that make up a 13.56 MHz turned circuits that serves as the antenna. The recent new RFID standard is called Gen 2 for second generation. It is a standard developed by more than 60 companies worldwide. The standard is under auspices of EPC Global, the organization that also standardized the Electronic Product Code or EPC to be used on all tagged items. The Gen 2 standard operates in the 900 MHz region within different frequencies being used in different countries depending upon the local regulations. A key benefit of the new standard is that it is designed to read multiple tags faster. Tag read rates as high as 1,000 tags per second are possible. Although in most situations, the read rate will be no more than 500 to 1,000 tags per second, which is still much faster than the 100 tag per second maximum imposed by the older standard. The RFID field is still new but growing as tag prices drop and as greater security measures are developed. One of the newest forms of wireless is a version of RFID called Near Field Communications or NFC. It is an ultra-short-range wireless whose range is rarely more than a few inches. It is a new technology used in smart cards and cell phones to pay for purchases or gain admittance to some facilities. Near field means the near field of a radio wave. As discussed earlier, a radio wave is made up of both electric and magnetic field. The electric field is not useful, but the magnetic field is used for short-range communication. NFC is standardized internationally. The new technology is similar to that used in RFID. It is similar to and compatible with the technology used in smart cards. Those credit cards with an internal chip that allow you to pay for something by just passing the card over a point of sale or POS terminal reader. Another proposed use is to set up and initiate other forms of wireless. Some short-range wireless modes such as Wi-Fi or Bluetooth require that two parties desiring a peer-to-peer link first exchange information to set up the correct protocol. It is sometimes called pairing. Putting your cell phone, laptop, or other device next to the device to be connected to allows all these protocols set up. One form of wireless is known as ultra-wideband or UWB wireless. There are two basic forms of UWB. The original version based The newest form of UWB is called multiband OFDM or MB OFDM UWB. The term multiband is derived from the fact that many OFDM carriers make up the signal. These bands extend from 3.168 to 4.952 GHz. Note the center frequencies of the three bands. Each band is designed to hold an OFDM data signal. There are 128 carriers per band and each carrier has a bandwidth of 4.125 MHz. Of the bands, 100 actually carry the data, while 12 are used as pilot carriers to aid in establishing communications with nearby nodes. The remaining carriers serve as guard bands on either side to prevent interference between the three portions of the spectrum. Figure 21-24, you will see a dashed line that designates the maximum allowed operating power specified by the FCC. It is a very low negative 41 dBm per megahertz, which generally prevents any interference to other services. The primary application of impulse UWB to date has been in military radar. The very short pulse widths of electromagnetic energy permit the very fine resolution of target distance and detail. Short pulses also give UWB the ability to penetrate surfaces to see what is behind them. For that reason, UWB is an excellent electronic imaging technique. It is especially effective in seeing through leaves, trees, and foliage. UWB radars can even see underground to detect mines, pipes, and so on. UWB radar is used by fire, emergency, and police personnel to see through walls and doors. These systems will operate in the 24 to 29 GHz range and are expected to appear in cars before 2010. There are several target markets for UWB. First is computer peripherals. UWB, when married to the popular PC and laptop USB interface, permits a wireless USB connection. USB is used almost exclusively today for connecting devices to PCs and laptops, such as printers, mice, external drives, and networking equipment. By making the interface wireless, cables and the hassle of connecting them are eliminated.